So now, as in the previous class, I have taught you about the verification of the zeros and the coefficients of a quadratic polynomial. So today we are going to form a quadratic polynomial when their zeros are given or sum of the zeros and product of the zeros will be given. In the first question here, alpha plus beta sum is given as 1 by 4 and alpha into beta product is given as value p minus 1. This also the same. But in the third question, the separate value of alpha and the beta are given 2 plus root 2 and 2 minus root 2. So two varieties of questions are here. So our formula will be applicable for this: k into x square minus sx plus p. So our formula is f of x is equals to k into x square minus sx plus p. So what we have to do, the value of s directly is given 1 by 4, that is alpha plus beta, where s is our alpha plus beta here and product p is alpha into beta. So value of s is 1 by 4 x square minus 1 by 4 into x, and value of alpha into beta, that is p, is minus 1 plus of minus 1, which becomes k into x square minus 1 by 4 x minus 1. You can leave it as such also, no need of taking any LCM. Now the second question, again the same type of question, alpha plus beta is sum 0 and product alpha into beta is p. So again the same formula, f of x equals to k into x square minus sx plus p, k into x square, as the sum alpha plus beta is given 0, so in place of s we place here 0 into x, and alpha into beta is given to us root 5, so plus root 5, which becomes k into x square plus root 5, that is our required quadratic polynomial. Now the third variety of, that is third question, is the second form, that is separate zeros are given. 2 plus root 2 is not alpha plus beta, it is a single zero of alpha, and 2 minus root 2 is not a product of the zero, it is actually a beta. So we will calculate first sum alpha plus beta is equals to 2 plus root 2 plus 2 minus root 2 minus root 2 plus root 2 cancel, 2 plus 2 4. So this is the value for our s. Now in the same way, product alpha into beta, which is equals to 2 plus root 2 into 2 minus root 2. So we get in the form of a plus b into a minus b. So 2 square minus root 2 the whole square, a square minus b square, 4 minus 2 will be equals to 2. Now required quadratic polynomial will be now f of x will be equals to k into x square minus sx plus p. So now as we calculated the value of s as here 4, so we replace the value 4 here, and as we got the value of product as 2 plus 2, so this will be our required quadratic polynomial. So whenever this type of questions comes in examination, you must be careful about reading the question again and again, whether the sum and product are given directly or the separately the two zeros are given. If the separately two zeros are given, you have to first get the sum by adding them and then product by multiplying them, and then you have to substitute in the formula. Otherwise we can do it directly in substituting in the formula. Now we come to the next topic, relationship between the zeros and the coefficients of a cubic polynomial. As in the previous class we have studied about the general form of the cubic polynomial, that is given by f of x equals to ax cube plus bx square plus cx plus d. The value of a never equals to 0, b, c and d can be equal to 0, and now here the coefficients are Here the coefficients are A, B, C and D, and zeros. As it is a cubic polynomial, it has three zeros, three roots and three solutions. So first zero we represent by alpha, second zero we denote by beta, and the third zero we denote by gamma. So here three zeros, as the degree of a cubic polynomial is 3. So 3 roots, 3 solutions, or we can say 3 zeros. Now we have to take the relationship between these 3 and this coefficients. So there will be 3 relations. Alpha plus beta plus gamma will be equals to minus b by a, and taking the product 2 at a time and their sum, alpha into beta, beta into gamma, gamma into alpha will be equals to d c by a, and at last taking all the three product, alpha into beta into gamma minus d upon a. So now as we are verifying the relationship between the zeros and the coefficients of a quadratic polynomial, two relations. Now in this case, for a cubic polynomial, we have to verify the three relations between its zeros and the coefficients. That is the first relation, alpha plus beta plus gamma equal to minus b by a, alpha into beta plus beta into gamma plus gamma into alpha equal to c by a, alpha into beta into gamma equals to minus d by a. Now let us discuss one question related to the verifications of the zeros and the coefficients of a cubic polynomial. The question is here: verify that 1 by 2, 1 minus 2 are the zeros, and then verify the relationship between their zeros and the coefficients of a cubic polynomial 2x cubed plus x square minus 5x plus 2. So what we have to do it, first we have to check whether this 1 by 2 is a solution or zero or root of this polynomial is correct or not. Then for second one 1, and then at last for minus 2. As in the previous class, 9th class, you might have studied that when we are going to find out the value of a polynomial at 1 by 2, 1 and minus 1 by 2, if it is a solution, if they are the zeros or roots, our answer, our value of the polynomial will be equal to 0. So let's verify first f of 1 by 2. So 2 into 1 by 2 the whole cube plus 1 by 2 the whole square minus 5 into 1 by 2 plus 2. So 2 into 1 by 8 plus 1 by 4 minus 5 by 2 plus 2, it becomes 1 by 4. 1 by 4 plus 1 by 4, 2 by 4 minus 5 by 2 plus 2 equals to, it again becomes 1 by 2 minus 5 by 2 minus 5 by 2 plus 2. Now if you take LCM as 2, 1 minus 5 plus 4, which becomes 5 minus 5 by 2 equal to 0 by 2 equal to 0. So this x equals to 1 by 2 is our solution, as the value for this point it comes equals to 0. So this 1 by 2 we can take it as now alpha. Now the second one, f of 1 is equals to 2 into 1 cube plus 1 square minus 5 into 1 plus 2. That becomes 2 plus 1 minus 5 plus 2. 2 plus 1 3 minus 5 plus 2 minus 3 equal to 0. Again the value comes for at this point x equals to 1 0. So this is also a x equals to 1 is also a 0 or root or solution of the cubic polynomial. So second value we can consider as beta. Now for the third one, f equals to x minus 2. 2 into minus 2 the whole cube plus minus 2 the whole square minus 5 into minus 2 plus 2, which comes now minus 2 ka cube, that is 2 into minus of 8, and minus 2 ka square it will become plus 4, minus 5 into minus 2 plus 10 plus 2, that becomes minus 16 plus 14 plus 2 16, which again comes equals to 0. Therefore it is also a solution of the given cubic polynomial, and this now we can consider as a gamma. Now we have to verify the relations. Let's start its verification. So here the value of A is 2, value of B is 1, value of C is minus 5, and value of B is 2. So first relation alpha plus beta plus gamma equal to minus b by a, and LHS we solved alpha plus beta plus gamma, that is 1 by 2, 1 minus 2, we got after solution minus 1 by 2. RHS it is minus b by a, so value of b is here 1, so minus 1 it becomes, and 2 value of a, that is 2 minus 1 by 2, both are equal. Therefore alpha plus beta plus gamma equals to minus b by a. This is verified. Now second one is given alpha into beta plus beta into gamma plus gamma into alpha is equals to c by a. So LHS of it, alpha into beta plus beta into gamma plus gamma into alpha. Value of alpha is our 1 by 2 into 1, value of beta is 1 into gamma minus 2 plus gamma minus 2, and alpha is 1 by 2. So 2 and 2 cancels. So 1 by 2 minus 2, and it becomes minus 1. So 1 by 2 minus 3, that is 1 minus 6 upon 2, that is minus 5 by 2. So RHS is our C by A, and value of C is minus 5 and value of A is 2, minus 5 by 2. So this is also correct. So it is verified that LHS is equals to RHS. Now the third relation, alpha into beta into gamma is equals to minus of B by A. So LHS of it, alpha into beta into gamma, value of alpha is 1 by 2 into 1 into minus 2, that becomes equals to minus 1, and RHS is equal to minus D by A. Value of D is our having here 2, and value of A is also 2. So minus 2 upon 2, which is equals to minus 1. So again verified. So therefore we can say that here also LHS is equals to RHS. So this is the way how to prove that the given 3 points are the solutions of the given cubic polynomial, and we can take any of it as alpha, beta and gamma, and then we have to verify the 3 relations. Thank you.